Hello everyone, welcome back. Today we're going to talk about element number 19, potassium. Chemical symbol, K. So let's get into this. Radioactive bananas. At least that's how the headline might read if a reporter got hold of half the facts. The reassuring truth is that virtually everything you eat is radioactive. Bananas, just a bit more so. Bananas are rich in the important nutrient potassium, and about 1/100% of the potassium atoms in the world are the radioactive isotope potassium-40. If you had $100 worth of potassium, 1 cent of each $100 that you have would be equivalent to the amount of radioactive potassium-40 that exists. So per each $100, you have 1 cent of potassium atoms that are radioactive. So the potassium that exists in the food that you eat, the radioactive potassium atoms would be 1 cent out of each $100. So in order to have 5 radioactive atoms, you would need to have $500 to have 5 cents of those radioactive potassium atoms. This trace accounts for a significant fraction of the natural background radiation we are all exposed to every day. Background radiation is the radiation that is present in the natural environment. Natural background radiation is all around us, all of the time. It makes up over half of our yearly exposure to radiation. The amount of background radiation is different at every location, according to United States Environmental Protection Agency.gov. www.epa.gov. Radtown background radiation. Background radiation, US EPA. Sources of background radiation include radon gas, food, medical tests, cosmic rays, and nuclear tests. Intriguingly, the writer Isaac Asimov speculated that the level of potassium-40 radiation, which has been decreasing on a billion-year timescale since the formation of the Earth, determined the window of opportunity for intelligent life to evolve. Isaac Asimov was an American writer and professor of biochemistry at Boston University. During his lifetime, Asimov was considered one of the big three science fiction writers, along with Robert A. Heinlein and Arthur C. Clarke. A prolific writer, he wrote or edited more than 500 books, according to Wikipedia. Too much potassium-40 in the early Earth prevented the formation of fragile long genomes. Too little potassium-40 later on would make the rate of mutation, and thus the rate of evolution, too slow to accomplish much. Pure speculation, of course, but it is interesting to reflect on the idea that without radiation-induced mutation, we might not be here to speculate. Potassium, radioactive or otherwise, is one of the alkali metals, and therefore fun to throw into water. More reactive than sodium, element number 11, potassium bursts into beautiful violet flames the instant it hits water. Here we have an image. Typically, with such explosive force that the fire is spread some distance in all directions. Here we have an image of potassium. Potassium is a soft alkali metal that is easily cut, revealing a bright silvery white surface that quickly tarnishes in air. It is most safely stored under dry oil. When potassium encounters water, you do not want to be too close. Here we have the unbalanced and balanced formula of potassium reacting with water to create potassium hydroxide and hydrogen gas, which is what's happening here. In the body, potassium in the form of the K+ ion is critical to nerve transmission. If levels get too low, fingers start to freeze in place and death follows if the deficiency reaches the heart. The cure, if medical care is not immediately available, is to eat bananas. Potassium keeps things moving in the body, but calcium is what keeps the body in shape, as we previously mentioned in the calcium video. I'll leave a link in the description below if you're interested in learning about the calcium element. Here we have an image of potassium chloride. Sodium-free salt, potassium chloride, is very slightly radioactive. Here we have an image of potash. Sulfate of potash, potassium sulfate, is a common fertilizer. We'll talk more about that. Here we have an image of potassium in a vial. Admirably shiny potassium prepared by a collector in Germany. Keeping the metal free of oxidation is extremely difficult. Here we have an image of a banana. Bananas are high in potassium, thus both healthy and radioactive. Potassium, element number 19, chemical symbol K. Soaps. Potassium hydroxide is used to make soaps. Potassium compounds are also used in fertilizers. In our bodies. In humans, potassium ions regulate blood pressure and transmission of nerve impulses. Radioactivity. The potassium-40 isotope causes low-level radioactivity in bananas, as well as humans and animals. Potassium, element number 19, the alkali metals. We are here on the periodic table. Its symbol is K, its atomic number is 19, its atomic weight is 39.098, its color is silver, its standard state is solid at 25 degrees Celsius or 77 degrees Fahrenheit. Its classification is metallic. I am sodium's twin. I am soft and react with air, so storing me under oil is essential. This small precaution keeps me isolated from contact with air or water. My ions can be easily detected in any substance since they give off a bright iliac flame. Just as dazzling is my explosive reaction with water, which is even stronger than that of sodium. Everyone knows that I can be found in bananas, but I bet you didn't know that I am central to many processes in your body. Most vitally, I aid the function of the nerves, allowing the brain to transmit information to the muscles. But too much of me in the body can lead to a heart attack, and this is my darker side. In the US, potassium chloride is used in the lethal injections that kill death row prisoners. Potassium's date of discovery was in 1807. Here we have a map of 1807 CE. Its density is 0.856 grams per centimeters cubed. Its melting point is 63.38 degrees Celsius or 146.08 degrees Fahrenheit. Its boiling point is 759 degrees Celsius or 1398 degrees Fahrenheit. Potassium, chemical symbol K. Potassium, element number 19, chemical symbol K. This metal helps the nerves and muscles in the body work properly. Potassium is found in foods such as bananas and avocados. Its compounds are used in soaps, plant fertilizers, and gunpowder. Its atomic mass is 39.098, its state is a solid, and its date of discovery was in 1807 by Sir Humphrey Davy. Here we have an image of pure potassium. A layer of dark oxide covers the outside of the metal, seen here, and here's the pure potassium that is cut and not oxidized because it was protected by the oxide layer. Here we have an image of a nugget of potassium. Potassium, element number 19, chemical symbol K. With its low density, potassium is a typical group 1 metal. Like all alkali metals, potassium reacts with water to form an alkaline solution and flammable hydrogen gas. It is a key ingredient in many industrial products, such as fertilizers, plays a key role in regulating our muscular and nervous systems, and is important in our diet. Soft metal. Here we have an image of potassium. Here we have the oxidized form of potassium, a layer of compound called potassium oxide. Potassium is a soft metal that can be cut with a knife. This shiny silvery metal tarnishes quickly when it reacts with oxygen in the air. This reaction forms a dull layer on the metal surface. Cutting the metal again reveals the shiny surface once more. Potassium in food. Several foods contain potassium. This useful element keeps the brain, nerves, and muscles functioning normally. Bananas are often considered to be potassium rich, but many other foods have higher percentages of potassium. A cup of coconut water, for example, has 0.02 ounces, 600 milligrams of potassium, compared to 0.015 ounces, 422 milligrams in a banana. Here we have an image of potassium-rich foods: coconuts, banana, celery. Sylvite. Here we have an image of sylvite, a naturally occurring mineral of potassium. Sylvite is composed mainly of the compound potassium chloride. Sylvite is similar to halite, which is also known as sodium chloride or simply salt. Explosive quality. Potassium chlorate, a compound of potassium chlorine and oxygen, is used in the manufacture of matches. When a match is struck, phosphorus and potassium chlorate mix in small amounts and then ignite. Here we have an image of a match. The pink match head contains sulfur and potassium chlorate. Plant food. Potassium is an essential element for plant growth. Its compounds are used extensively in fertilizers, along with phosphorus and nitrogen. In fact, fertilizers are often referred to by their NPK, nitrogen, phosphorus, potassium content. Here we have an image of a tractor spraying potassium-based fertilizer on a field. Let's continue with element number 19, potassium. Potassium uses today. The greatest demand for potassium compounds is in fertilizers. Many other potassium salts are of great importance, including the nitrate, potassium nitrate, carbonate, potassium carbonate, chloride, potassium chloride, bromide, potassium bromide, cyanide, potassium cyanide, and sulfate, potassium sulfate. Potassium carbonate is used in the manufacture of glass. Potassium hydroxide is used to make detergent and liquid soap. Potassium chloride is used in pharmaceuticals and saline drips. Common potassium fertilizer sources are potassium chloride, KCl, potassium sulfate, K2SO4, potassium magnesium sulfate, K2SO4, 2MgSO4, and potassium thiosulfate, K2S2O3. According to University of Minnesota, extension.umn.edu, phosphorus and potassium. Potassium for crop production, UMN extension. The word potassium is derived from potash. Here we have some information on potassium nitrate. Potassium nitrate is a chemical compound with a sharp, salty, bitter taste and the chemical formula KNO3. This alkali metal nitrate salt is also known as Indian saltpeter. It is an ionic salt of potassium ions K+ and nitrate ions NO3 negative, and is therefore an alkali metal nitrate. It occurs in nature as a mineral niter, according to Wikipedia. Its chemical formula is KNO3. Its molar mass is 101.1032 grams per mole. Its IUPAC ID is potassium nitrate. Its melting point is 633.2 degrees Fahrenheit or 334 degrees Celsius. Its density is 2.11 grams per centimeters cubed. Its boiling point is 752 degrees Fahrenheit or 400 degrees Celsius. It's soluble in water, ammonia, and glycerol. Niter. Niter or nitre is the mineral form of potassium nitrate, KNO3. It is a soft, white, highly soluble mineral found primarily in arid climates or cave deposits, according to Wikipedia. Here we have some information on the mineral. Niter was used during the Civil War as a component in gunpowder. It is now used in the manufacture of glass, matches, explosives, and fertilizers, according to MFA.org. Cameo.mfa.org, Wiki Niter. Niter, MFA, Cameo Database, Museum of Fine Arts, Boston. Is saltpeter the same as niter? Saltpeter, also called saltpeter, also called nitre or niter, any of three naturally occurring nitrates distinguished as 1. Ordinary saltpeter or potassium nitrate, KNO3, 2. Chili saltpeter, cubic nitre, or sodium nitrate, NaNO3, and 3. Lime saltpeter, wall saltpeter, or calcium nitrate, CaNO3, 2. According to Britannica.com, www.britannica.com, Science, Saltpeter. Saltpeter definition, uses, and facts. Encyclopedia Britannica. Here we have the potassium nitrate molecule. Potassium bound to nitrogen and oxygen. The negative one and the positive one balance out, and the negative one here and the positive one balance out. Potassium carbonate. Potassium carbonate is the inorganic compound with the formula K2CO3. It is a white salt, which is soluble in water and forms a strongly alkaline solution. It is deliquescent, often appearing as a damp or wet solid. Potassium carbonate is mainly used in the production of soap and glass, according to Wikipedia. Its formula is K2CO3. Its molar mass is 138.205 grams per mole. Its IUPAC ID is potassium carbonate. Its melting point is 1,636 degrees Fahrenheit or 891 degrees Celsius. Its density is 2.43 grams per centimeters cubed. Its ChemSpider ID is 10949. It's soluble in water. Potassium carbonate's usefulness as a raw material for soap is that instead of burning alkalis and then converting fatty acids to soap, the fats are neutralized by both the sodium and potassium, according to AG Chemi Group. blog.agchemigroup.eu. Potassium carbonate for soaps and detergents. Potassium carbonate is primarily used as a flux in glass production. It increases the resistance, transparency, and refractive coefficient of glass to give it excellent clarity, making it ideal for use in spectacles, glassware, television screens, and computer monitors, according to Vinova Group, www.vinovagroup.com. Block potassium dirty. Crystal clear. The role of potassium carbonate in glass. Here we have the molecule of potassium carbonate. 2 potassiums bound to 1 carbonate molecule, carbon, and 3 oxygen atoms. The 2 oxygens form a negative, and the 2 potassiums form a positive, and that binds the molecule together. Potassium chloride. Potassium chloride is a metal halide salt composed of potassium and chlorine. It is odorless and has a white or colorless vitreous crystal appearance. The solid dissolves readily in water, and its solutions have a salt-like taste. Potassium chloride can be obtained from ancient dried lake deposits, according to Wikipedia. Its formula is KCl. Its molar mass is 74.5513 grams per mole. Its melting point is 1,418 degrees Fahrenheit or 770 degrees Celsius. Its boiling point is 2,588 degrees Fahrenheit or 1,420 degrees Celsius. Its density is 1.98 grams per centimeters cubed. Its ChemBl ID is 1200731. It's soluble in water and glycerol. The chlorine ion is negative and the potassium ion is positive. They form an ionic compound whose molecules consist of 1 potassium atom and 1 chlorine atom. It is a white to colorless face-centered cubic crystal, according to Britannica.com. Here we have an image of potassium chloride saline drips. Usually saline fluids combine sodium chloride and sterile water. Our saline solution uses 0.9% sodium chloride. The water in IV fluids rehydrates the body, which is about 60% water, according to Rocky Mountain IV Medics. RockyMountainIVMedics.com. Ingredients in our IV drips. What's in an IV bag? Ingredients in our IV drips. Usually the IV drips have sodium chloride, but in special cases it has potassium chloride, Potassium chloride is a medication used in the management and treatment of hypokalemia. It is in the electrolyte supplement class of medications. This activity outlines the indications, action, and contraindications for potassium chloride as a valuable agent in the management and treatment of hypokalemia. According to National Institutes of Health.gov, hypokalemia is a human disease. Hypokalemia is a low level of potassium in the blood serum. Mild low potassium does not typically cause symptoms. Symptoms may include feeling tired, leg cramps, weakness, and constipation. Low potassium also increases the risk of an abnormal heart rhythm, which is often too slow and can cause cardiac arrest. There are 3 primary fluids used for resuscitation. Each contains varying amounts of potassium per liter. Table 1, 0.9% sodium chloride, normal saline, lactated ringer solution. According to Academic Life in Emergency Medicine, www.alium.com, lactated ringer solutions. Is lactated ringer solution safe for hyperkalemia patients? Do IV drips have potassium? Potassium IV solutions should be administered only in well-hydrated patients and with adequate urine flow, especially in post-surgical patients. Potassium acetate, potassium chloride, and potassium phosphate are available as concentrated solutions that require dilution before intravenous administration, according to NIH.gov. https www.ncbi.nlm.nih.gov. Books, NBK 539791. Potassium Stat Pearls, NCBI Bookshelf. Which IV fluid contains potassium? Potassium chloride 0.3 and sodium chloride 0.9 solution for infusion is indicated for the prevention and treatment of potassium depletion and or hypokalemia in sodium chloride and water-losing conditions, according to Electronic Medicines Compendium. www.medicines.org.uk EMC product SMPC. Potassium chloride 0.3% WV and sodium chloride 0.9% WV. Normal saline drip. An IV fluid drip involves a small tube called a catheter and a saline-based electrolyte solution that contains your selected vitamins and nutrients. An IV drip delivers these essential nutrients and fluids directly into your bloodstream, bypassing your digestive tract. According to Bounce Hydration, www.bouncehydration.com. How IV drips work. What are IV drips and how do they work? Bounce Hydration. Is lactated ringer solution safe for hyperkalemia patients? Lactated ringers has a potassium concentration lower than that of patients with hyperkalemia. Therefore, it is safe for these patients. It may be preferred over normal saline since it has a more neutral pH. Potassium hydroxide. Potassium hydroxide is an inorganic compound with the formula KOH and is commonly called caustic potash. Along with sodium hydroxide, KOH is a prototypical strong base. It has many industrial and niche applications, most of which exploit its caustic nature and its reactivity towards acids, according to Wikipedia. Its formula is KOH. Its molar mass is 56.1056 grams per mole. Its IUPAC ID is potassium hydroxide. Its melting point is 680 degrees Fahrenheit or 360 degrees Celsius. Its boiling point is 2,421 degrees Fahrenheit or 1,327 degrees Celsius. Its ChemSpider ID is 14113. It's soluble in water and glycerol. Potassium, hydrogen, and oxygen. Potassium has a positive 1 charge, and the oxygen bound to the hydrogen has -1. Bind together due to the differences in charges between the oxygen and the potassium. Potassium hydroxide. Potassium hydroxide, KOH, in soap and cleaning products. It is used in heavy-duty products for cleaning concrete, brickwork, and ovens, as well as more delicate cleaners, such as those used on dentures. It is also used to unclog drains and pipes. KOH, potassium hydroxide, is also present in non-phosphate detergents. According to AG Chemi Group, blog.agchemigroup.eu, uses for KOH in soap, energy and batteries manufactured. Potassium bromide. Potassium bromide is a salt widely used as an anticonvulsant and a sedative in the late 19th and early 20th centuries, with over-the-counter use extending to 1975 in the US. Its action is due to the bromide ion. Potassium bromide is used as a veterinary drug, as an anti-epileptic medication for dogs, according to Wikipedia. Its formula is KBr, its molar mass is 119.002 grams per mole. It's soluble in water, ethanol, and glycerol. Its density is 2.75 grams per centimeters cubed. Its melting point is 1,353 degrees Fahrenheit or 734 degrees Celsius. Its boiling point is 2,615 degrees Fahrenheit or 1,435 degrees Celsius. Type of compound, ionic compound, according to study.com. What is potassium bromide? KBr, or potassium bromide, is an ionic salt completely dissociated and has a value of pH 7 in an aqueous solution. It is also known as calibromidium, tripotassium, tribromide, and bromide salt of potassium. According to Vendatu, www.vendatu.com, potassium bromide. Potassium bromide, structure, properties, and production. So again, potassium bromide was widely used as an anticonvulsant, which prevents seizures, and nowadays it's used as an anti-epileptic medication for dogs. Epilepsy. A disorder in which nerve cell activity in the brain is disturbed, causing seizures. Epilepsy may occur as a result of a genetic disorder or an acquired brain injury, such as a trauma or stroke. During a seizure, a person experiences abnormal behavior, symptoms, and sensations, sometimes including loss of consciousness. There are few symptoms between seizures. Epilepsy is usually treated by medications and in some cases by surgery, devices, or dietary changes. Anticonvulsants. Anticonvulsants are a diverse group of pharmacological agents used in the treatment of epileptic seizures. Anticonvulsants are also increasingly being used in the treatment of bipolar disorder and borderline personality disorder, since many seem to act as mood stabilizers, and for the treatment of neuropathic pain, according to Wikipedia. Use: epilepsy. Synonyms: anti-epileptic drugs, anti-seizure drugs. ATC code NO3. Biological target: the brain. Sedative. A sedative or tranquilizer is a substance that induces sedation by reducing irritability or excitement. They are CNS depressants and interact with brain activity, causing its deceleration. Various kinds of sedatives can be distinguished, but the majority of them affect the neurotransmitter gamma-aminobutyric acid, according to Wikipedia. What does a veterinarian do? Veterinarians treat the injuries and illnesses of pets and other animals with a variety of medical equipment, including surgical tools and X-ray and ultrasound machines. They provide treatment for animals that is similar to the services a physician provides to humans, according to Bureau of Labor Statistics.gov, www.bls.gov, OOH, Healthcare Veterinarians. Veterinarians Occupational Outlook Handbook. Potassium bromide, the potassium and the bromine. The potassium is +1 and the bromine is -1, and they bind together ionically. Potassium cyanide. Potassium cyanide is a compound with the formula KCN. This colorless crystalline salt, similar in appearance to sugar, is highly soluble in water. Most KCN is used in gold mining, organic synthesis, and electroplating. Smaller applications include jewelry for chemical gilding and buffing, according to Wikipedia. Its chemical formula is KCN, its IUPAC ID is potassium cyanide, its molar mass is 65.12 grams per mole, its density is 1.52 grams per centimeters cubed, its boiling point is 2,957 degrees Fahrenheit or 1,625 degrees Celsius. Its melting point is 1,1 174 degrees Fahrenheit or 634.5 degrees Celsius. It's soluble in water and glycerol. Here we have potassium cyanide, positive 1, the potassium, and the carbon, negative 1, with the nitrogen seen here. Triple bond forms an ionic bond. The molecular formula is KCN. The molar mass of potassium cyanide is 65.12 grams per mole. Potassium cyanide is a compound formed of potassium, K plus cation, and cyanide, Cn negative anion, in which potassium is positively charged and cyanide is negatively charged ions, according to Vendatu. www.vendatu.com. Potassium cyanide, structure, properties, preparation, uses. Here we have some information on cyanide compounds. Cyanide is a fast-acting, bitter-tasting poison, and one of the deadliest known. Its compounds have famously been utilized in suicide pills over the years. History. Cyanide has been used for centuries as a poison, but was first identified in 1782 by the Swedish chemist Scheele. In fact, it's thought Scheele's death may have been contributed to by cyanide exposure. During World War I, the French attempted to use hydrocyanic acid, then cyanogen chloride, in chemical warfare. In World War II, the Nazis used hydrogen cyanide in the form of Zyklon B to kill millions in their concentration camps. Hydrogen cyanide gas has previously been used for pest control, which sometimes led to accidental deaths. Today, cyanides are still used in the mining of gold and silver, and in organic synthesis reactions. Effects: dizziness and headache, nausea and vomiting, rapid breathing and heart rate, low blood pressure, loss of consciousness, respiratory failure, convulsions, and death. Cyanide inhibits the cyclone oxidase enzyme, preventing the body's cells from using oxygen. HCN smells of bitter almonds, but only about 40% of people have the genetic ability to smell it. Many fruit seeds also contain small amounts of cyanide-containing compounds. Hydrogen cyanide, hydrogen with carbon nitrogen, potassium cyanide, potassium with carbon nitrogen, and sodium cyanide, sodium with carbon nitrogen. The carbon and the nitrogen are bound triply. Treatment. The most prevalent antidotes are nitrates, which convert hemoglobin into methemoglobin, which then removes cyanide from cytochrome oxidase. Thiosulfate helps convert cyanide to thiocyanide, so it can be excreted. Cobalt ions also form a stable complex with cyanide. Amyl nitrite, sodium thiosulfate, vitamin B12. How to detect cyanide. A common test for cyanide in the early 20th century formed Prussian blue, an iron cyanide complex, in the presence of cyanide ions. There are several other chemical tests, including portable card-based tests, and instrumental methods can also be used. The sample is added to 5% solution of sodium hydroxide for 1 minute. It's transferred to solution of 5% iron sulfate and 1% iron chloride. At 60 degrees Celsius, it's heated for 10 minutes. Adding hydrochloric acid solution gives Prussian blue, with a ratio of 1 to 6 HCl to H2O for 10 to 15 minutes. How does cyanide kill? Immediate symptoms: headache, nausea, vomiting, dizziness, rapid heart rate. Symptoms of longer exposure: unconsciousness, convulsions, respiratory failure, coma, and death. Treatment: get to fresh air. Rapidly wash body with soap and water. Seek medical care and remove clothing. Contact poison control. 1-800-222-1222. Here's some more information on cyanide. The reason we're talking about it is because of potassium cyanide. Potassium bound to C and N. The Central Pollution Control Board had already sounded a warning on the risks caused due to the heavy use of potassium cyanide by electroplating units. Cyanide and chromium-6 are the highly toxic chemicals used in plating baths and are lethal to humans. They are difficult to destroy or destabilize and dispose of in an environmentally sound manner. Due to lack of awareness, the chemicals are handled carelessly by laborers in the plating industry. The National Task Force, constituted by the board to study issues and provide guidance on containing the pollution from electroplating sector, suggested an action plan for phase-wise reduction of cyanide and hexavalent chromium in electroplating, it said. According to a report on the board, an expert committee it constituted to explore the possibilities of phasing out cyanide use in electroplating processes had recommended to phase out its use in zinc and copper electroplating processes. Why cyanide is used in electroplating? Metal deposits produced from cyanide plating solutions are more finely grained than those plated using an acidic solution. Moreover, cyanide-based plating solutions tend to be more tolerant of impurities than other solutions, offering preferred finishes over a wide range of conditions. Different compounds of cyanide. Cyanide is a fast-acting deadly chemical that mainly exists in two forms, gas or crystal. Hydrogen cyanide and cyanogen chloride are in gas form, while sodium cyanide and potassium cyanide are in crystal form. Cyanide is heavily used for various industrial purposes, including the purification of gold and electroplating. What does it do to human body? Cyanide kills the body's cells by starving them of oxygen. The poison is most harmful to the heart and the brain, which depend heavily on oxygen. Potassium cyanide is a gas because it's bound to hydrogen, and carbon is a gas, and nitrogen is a gas, normally carbon dioxide, nitrogen gas, the air that we breathe. The potassium cyanide and the sodium cyanide are found in crystal forms because the potassium and the sodium freezes the Cn into a crystal. The potassium cyanide and the sodium cyanide get converted to hydrogen cyanide by the stomach acid. The median lethal dose is 3 to 8 milligrams per kilogram. Oral varies depending on form of cyanide administered. And this is the treatment. The antidotes are nitrites. My theory is that because they provide the nitrogen for the nitrogen in the cyanide to bind to itself, and they provide oxygen that is needed from the depletion of it. Let's continue with potassium. Potassium sulfate. Potassium sulfate or potassium sulfate, also called sulfate of potash, arcanite, or archaically potash of sulfur, is the inorganic compound with formula K2SO4, a white water-soluble solid. It is commonly used in fertilizers, providing both potassium and sulfur. Potassium, sulfur, and oxygen. Potash includes various mined and manufactured salts that contain potassium in water-soluble form. The name derives from potash, plant ashes or wood ash soaked in water in a pot, the primary means of manufacturing potash before the industrial era. The word potassium is derived from potash, according to Wikipedia. The largest producer is Canada, according to canada.ca. A fertilizer or fertilizer is any material of natural or synthetic origin that is applied to soil or to plant tissues to supply plant nutrients. Fertilizers may be distinct from living materials or other non-nutrient soil amendments. Many sources of fertilizer exist, both naturally and industrially produced, according to Wikipedia. Here we have the potassium sulfate molecule, 2 potassium and the 2 oxygens, 2 negatives and 2 positives, bind the molecule together. Potassium sulfate is an ionic compound made of 2 potassium atoms, 1 sulfur atom, and 4 oxygen atoms. It has the chemical formula K2SO4, K2SO4. Potassium sulfate is considered an inorganic compound because it does not contain carbon-hydrogen bonds, according to study.com. Study.com, learn less in potassium sulfate. Potassium sulfate formula and uses. Study.com. Again, the three main nutrients are nitrogen, N, phosphorus, P, and potassium, K. Together, they make up the trio known as NPK. Other important nutrients are calcium, magnesium, and sulfur, according to New South Wales, www.dpi.nsw.gov.au, Soil Testing and Analysis, Plant Nutrients in the Soil. Let's continue with the element potassium. Potassium, as K+, is required by all plants and animals. Plants need it for photosynthesis, regulation of osmosis and growth, and enzyme activation. Every animal has a closely maintained potassium level and a relatively fixed potassium-sodium ratio. Potassium is the primary inorganic cation within the living cell, and sodium is the most abundant cation in extracellular fluids. In higher animals, selective complexants for Na+ and K+ act at cell membranes to provide active transport. This active transport transmits electrochemical impulses in nerve and muscle fibers and in balancing the activity of nutrient intake and waste removal from cells. Cell transport. Materials are constantly being transported in and out of the cell via the cell membrane. Such materials could include fuel for generating energy or building blocks essential for protein assembly, such as amino acids. Some cells can secrete signaling molecules to communicate with neighboring cells or the rest of the body. The cell membrane is largely composed of phospholipids, but it is also studded with proteins that facilitate transport, enable cells to communicate with one another, and identify a cell to other cells. The membrane is permeable to some molecules, but other molecules need active transport through special channels in the membrane. Cells have three main methods of transport: diffusion, facilitated diffusion, and active transport. The last requires energy, and as previously mentioned, selective complexants for Na+ and K+ act at cell membranes to provide active transport. Active transport. Molecules bind to a receptor site on the cell membrane, triggering a protein which changes into a channel that molecules travel through. Here you have molecule at receptor site, and protein forms the channel. The cell. It is hard to comprehend what 75 trillion cells looks like, but observing yourself in a mirror would be a good start. That is how many cells exist in the average human body, and we replace millions of these cells every single day. Potassium is utilized in the muscular system, it's pumped in the cardiovascular system, and is mainly applied in the nervous system as a means of electrical communication. The brain is the seat of consciousness and creativity, yet many of its functions are performed unconsciously. It controls the body's movements with the help of the spinal cord and nerves. It receives sensory information, controls the endocrine system, and maintains other systems. The components are brain, spinal cord, nerves, and sense organs. The electrical nature of nerve signals. Nerve signals are pulses of electricity caused by the mass movement of tiny particles called ions. Electrical charge is a fundamental property of matter. Minerals such as potassium and sodium dissolve in bodily fluids and exist as ions, each with a positive charge. The more ions in a certain place, the higher the charge. The fluids inside and outside of cells are electrically neutral, but there is a polarizing shell of charge containing every cell's membrane, and this creates the resting potential. When ions move across the membrane, the associated move of charge creates a pulse of electricity or action potential. An action potential measures about 100 millivolts from peak to trough, and is over in 1/250th of a second. Action potential. Ions move in and out of small patches of the axon's membrane to generate an action potential by changing the cell's voltage. Traveling signals. The region of reverse charge fizzes along the length of the axon, much like a lit fuse before passing the message on at a synapse. Charges across the membrane are disrupted ahead of and behind the depolarization. Positive and negative charges, the membrane voltage, millivolts, resting potential, and peak of depolarization. The membrane ahead starting to depolarize, the electrically active patch of membrane, and repolarization. Nerve cells. All body parts are made of cells. The nervous system's main cells are called neurons. The brain has at least 100 billion of them, and they communicate using a language of tiny electrical pulses or nerve signals. 1. Resting potential. Every nerve cell's sodium-potassium pump distributes sodium and potassium across the cell membrane, which creates differences in concentration and a polarization of electrical charge at the membrane. The resting potential, with the inside of the cell negatively charged. Here we have the potassium channel, the sodium channel. The potassium channel allows the flow of potassium ions. The sodium channel allows the flow of sodium ions. 2. Depolarization. A stimulus arrives and triggers voltage-gated sodium channels to open. Sodium moves into the neuron. Sodium ions flood into the neuron, causing a movement of positive charge. If this depolarization, reversal of the polarity of the membrane, achieves a critical level called threshold, the membrane generates an action potential. 3. Repolarization. The depolarization change in voltage causes sodium channels to snap shut and voltage-gated potassium channels to open. Now potassium ions move out of the neuron, removing the positive charge brought in by the sodium ions. In fact, a brief hyperpolarization occurs. Inside is even more negative, before returning to its resting potential. This active transport transmits electrochemical impulses in nerves and muscle fibers, and in balancing the activity of nutrient intake and waste removal from the cells. Too little or too much potassium in the body is fatal. However, potassium in the soil ensures the presence of this indispensable element in food. Here we have another example of the action potential with sodium and potassium. Resting potential, depolarization. The potassium gate is closed. The sodium gate is open for the sodium ions to flow in to the nerve cell. And then in repolarization, the potassium gate is opened and the sodium gate is closed. So the potassium ions flow out and the sodium ions stay inside. Temporarily, it's negative like in the beginning of the resting potential, and it's positive on the outside, and then it returns back. The sodium ions are returned to the outside, and the potassium ions are returned to the inside. Mapping out the ions, we see the positive charge. We see the positive charge on the outside, and then on the inside, and then on the outside again, and then it rests. And then we see the negative charge on the inside, and then on the outside, and then on the inside again, and then it rests. It's similar to the way that alternating current works. Alternating current, AC, is a type of electrical current in which the direction of the flow of electrons switches back and forth at regular intervals or cycles. Current flowing in power lines and normal household electricity that comes from a wall outlet is alternating current. Our nerve cells work similar to the way that alternating current works, using electricity and the flow of ions, specifically, again, potassium and sodium. The potassium content of plants varies considerably, though it is ordinarily in the range of 0.5 to 2% of the dry weight. In humans, the ratio of potassium between the cell and plasma is approximately 27 to 1. The potassium content of muscle tissue is approximately 0.3%, whereas that of blood serum is about 0.01 to 0.02%. Here we have some information on the muscular and the cardiovascular system. Muscular. Muscles work with the skeleton, providing pulling force for movement. Involuntary muscles control internal processes such as digestion and blood distribution. Nerves control the muscles, and the circulatory system supplies them oxygen. The components are skeletal muscle, tendons, smooth muscle and organs, and cardiac muscle. Skeletal muscles connected to the bones. The tendons are what connects the muscles and the bones. The smooth muscle are the muscles that move the food around, your digestive system muscles. And the cardiac muscles are the heart muscles that need to pump throughout your whole life. Cardiovascular. This system pumps blood around the body. It supplies the tissues with oxygen and nutrients and carries waste products from them so that they can be expelled. It also transports hormones and immune cells to the points where they are needed. The components are heart, arteries, veins, arterioles, venules, capillaries, blood, plasma, and red and white cells. The dietary requirement for normal growth is approximately 3.3 grams, 0.12 ounces of potassium per day, but the ingestion of more than 20 grams, 0.7 ounces of potassium results in distinct physiological effects. Excess potassium is excreted in the urine, and a significant quantity may be lost during sweating. Let's continue with element number 19, potassium. Potassium chloride, KCl, is a naturally occurring potassium salt that, aside from its use as fertilizer, is also a raw material for the production of other important potassium compounds. Electrolysis of potassium chloride yields potassium hydroxide, also called caustic potash, seen here, which readily absorbs moisture and is employed in making liquid soaps and detergents and in preparing many potassium salts. Reaction of iodine and potassium hydroxide produces potassium iodide, Ki, which is added to table salt in animal feed to protect against iodine deficiency. Iodized salt. As we talked about in the iodine video, if you have the non-radioactive form of iodine in your thyroid, if presented with the radioactive form of iodine, will act as a shield to block out the radioactive iodine and keep you safe from radioactivity. Specifically from the radioactive iodine I-131. The compounds presented here are potassium iodine, potassium chloride, and potassium hydroxide. Potassium iodide is a chemical compound, medication, and dietary supplement. It is a medication used for treating hyperthyroidism in radiation emergencies and for protecting the thyroid gland when certain types of radiopharmaceuticals are used, according to Wikipedia. Its formula is Ki, its molar mass is 166.0028 grams per mole. Its IUPAC ID is potassium iodide. It's soluble in water. Its melting point is 1,258 degrees Fahrenheit or 681 degrees Celsius. Its density is 3.12 grams per centimeters cubed, and its CH-EMBL ID is 1141. One atom of potassium bound to one atom of iodine. Potassium iodide is an inorganic chemical compound which is denoted by the chemical formula Ki. Potassium iodide is a metal halide salt featuring an ionic bond between the potassium cation K+ and the iodide ion I-. It is colorless to white. It appears as cubical crystals or powder or white granules. According to Bajus.com, chemical compound formulas, potassium iodide, Ki, structure, properties, and uses of Ki. The potassium ion is positive and the iodide ion is negative. They form an ionic bond and bind together to form the salt. From potassium hydroxide, the unbalanced and balanced formula, KOH, plus I2 creates Ki, OH. Potassium chloride. Again, here we have the electrolysis of aqueous potassium chloride. Water and electrons create hydroxide and hydrogen gas. Potassium chloride and electrons create potassium and chlorine. The potassium and then the hydroxide create potassium hydroxide. Not exactly the process, but it's the chemical equations that create potassium hydroxide. KOH in soap and cleaning products. Iodine in the form of iodide is added to table salt to prevent iodine deficiency. Since the 1980s, there have been efforts to have universal salt iodization. This has been an affordable and effective way to combat iodine deficiency around the world. But not all salt contains iodine, however. According to Scientific American, www.scientificamerican.com article. Salty Science. Is there iodine in your salt? Scientific American. Potassium iodide, Ki, is a type of iodine that is not radioactive and can be used to help block one type of radioactive material, radioactive iodine 131, from being absorbed by the thyroid, according to Centers for Disease Control and Prevention.gov. www.cdc.gov. NCH radiation emergencies. Potassium iodide, Ki, radiation emergencies. NCEH CDC. Let's continue with element number 19, potassium.